Hello, this is mathswithlemon.io, new website, and in this topic we will explore the difficult, supposedly, part of the IBHL course AA, which is proofs. Proofs is under the umbrella of number theory, which is the most amazing part of mathematics. And now we'll explore one of the classical problems, IB question, which is the following one. Use the method of mathematical induction to prove that this series is equal with n over n plus 1. Now, what you have to do, first of all, I have to follow 3 steps. On the website you can find all the theory that you have to know. There are also their examples, and this is the following process. So if you didn't check it, check it. So first, I want to show that the statement is true for what? For n equals, now this is where you have to be cautious. You go and check always what they give you as a condition. Here the condition is that n should be an integer, meaning 0, 1, 2, 3, 4, 6, 7 and so on. But here it's integer plus, which means without 0. So which is the first term? Well, the first term for n equals 1. So what I will do, first I will check the left hand side, which is the series for r equals 1, so it's going to be 1 over 1, 1 plus 1, which is 1/2. Done. I go to the right hand side now, and I'm checking where n is 1, when n equals 1, 1 over 1 plus 1, which is 1/2. Correct for both of them? I'm going further down. Now, what's the second part? The second part here now, you will assume that this is true for r equals 1 up to k. So now, immediately, my expression on the right hand side, r plus 1, is going to be true for k plus 1. Now this is something that I will use further down. Now I will go and prove the statement for n equals k plus 1. Now this is the most important part. Here for nk plus 1, n equals k plus 1, I have to go and check what it will give me at the end as an answer. So I want to put on this expression, on the expression n plus 1, I will go and I will put k plus 1 instead of n. So it's going to be k plus 1, k plus 1 plus 1. So it's going to be k plus 1 over k plus 2. This is where I have to end with my proof. So here I have to see how I will manipulate my proof while I'm proving it to end up to this. It's pretty easy. I will start that the sum for r equals 1 up to k plus 1 of this expression is, well, now here is the little, it has a little twist. Now, what does that mean? Well, it means that, listen, your sum from the series from 1 up to k plus 1 terms, how it's going to be? Well, it's going to be the sum of r equals 1 up to k of this expression plus one more term, which is going to be what? 1 over, now the term is going to go to the place of r, k plus 1, and the other r, k plus 1 plus 1, which is going to give me the sum r equals 1, k 1 over r plus 1 plus 1 over k plus 1, and this is going to be k plus 2. And now is where I will use here, this part is what I assumed from the previous, my series are equal with. You see it here. This one is what you will use. So how much is it? Well, it's k over k plus 1. So all this sum is equal with k over k, no plus 1, k plus 1, correct, plus 1 over k plus 1, k plus 2. Let me continue here. Now, here, if you're good with the algebra, this is the only part where you will utilize it. So if you have good algebraic skills, this is going to be easy. What should I do here? Well, I have two fractions. I want them with the same denominator, so I will multiply this fraction by k plus 2, numerator and denominator. So I will have k times k plus 2 over k plus 1 times k plus 2 plus 1 over k plus 1, k plus 2. Let me add the numerators. This by expanding, k squared plus 2k plus 1 over k plus 1 times k plus 2. And now this is the point where when you were grade 10, grade 9 or year 10, year 11, doesn't matter, we were telling you learn to expand the perfect square because you have also to be able to factorize it, the expanded form. So this one is the expanded form of, if you remember, a plus b squared is a squared plus 2ab plus b squared, where a is k and b is 1. So this one can be written k plus 1 squared over k plus 1 times k plus 2. Here what I have, bam, goodbye. So I'm left with k plus 1 over k plus 2. Proved. Easy? I think yes. Stay tuned, more videos coming.